What is the source for the topography data, and what is its accuracy?
The API we currently use is GPXZ.io. The resolution depends on the location, but for most of the world it is between 0.5 and 30 meters. Note that the constructions and vegetation are not included, and you can find more details on the GPXZ.io page or in the PVsyst help at the link below.
How to work with the imported topography in PVsyst? Can we align objects on the topography? And how to make the PV system geolocation coincide with it?
In PVsyst, only the site is geolocated. Neither the PV tables nor the topography have a precise geolocation, which means that their relative XY positioning needs to be adapted by moving the PV tables according to the ground image data. You can adjust an existing array correctly placed in the XY plane to follow the topography by using the automatic altitude tool. This currently adjusts only the height of the tables, but this functionality will eventually be improved to adjust the tilts according to the topographic layer. If you create your PV arrays in PVsyst, using the options of the zone tool will ensure that the height and tilt correspond to the underlying topography.
Are there other ways to import topographic layers in PVsyst? Is there any documentation on importing the topography?
Yes, the topography can also be imported from a file like in PVsyst 7. A PDF tutorial exists named Import Topography. It can be found within PVsyst by clicking on Help, PDF Tutorials, Ground and Topography, or on the PVsyst webpage.
Is it possible to use bifacial model to simulate east-west domes in PVsyst 8?
Although separate orientation can each have their own bifacial model in PVsyst, it is not yet possible to simulate the bifacial gain of alternating fixed east-west structures called domes in PVsyst. Note that in most cases the bifacial gain of such structures is negligible, so deactivating the bifacial model is actually a viable option.
How to define different bifacial orientations?
In PVsyst 8.0, each orientation may or may not have its own bifacial model. To properly configure it, in the System window, you should enter each subarray that is assigned to such a bifacial orientation. There, you can select a bifacial module and enter the bifacial system page. On that page, a bifacial model and its detail can be selected for the current orientation. Note that you can define identical orientations if you need to have different sets of bifacial models, for example, for different table width or for pitch distances.
Can PVsyst simulate vertical bifacial systems? And how are shading considered for the rear side?
Yes, PVsyst can simulate vertical bifacial systems. In the current bifacial model, the shadings that affect the rear side are either automatically accounted for in the case of mutual row-to-row shadings, or they can be added as a percentage factor in the case of other structural shadings. 3D scene shading objects are not yet considered for the backside.
Why can the pitch and number of rows be defined by the user now?
These new options are relevant if there are outliers in the row-to-row distribution or if there is only a single PV table. In such a case, PVsyst is not able to identify the pitch properly from the 3D scene, and it is necessary to specify it manually. The number of rows is there to be overridden in case PVsyst does not count the rows correctly, which currently happens in certain complex cases.
What is the link between PVsyst CLI versions and PVsyst versions? Can PVsyst CLI run with the PVsyst 7 engine?
PVsyst CLI updates will always mirror the PVsyst updates. For a given version, the results from PVsyst CLI will be the same as those obtained when running PVsyst. This also means that PVsyst CLI cannot run based on the PVsyst 7 engine, only the PVsyst 8.
What are the limitations in the usage of CLI? Can we integrate it with other models, into other products, or into other complex workflows?
The only limitations for the usage of CLI are that it is limited to a single installation, but it can run on a server or be parallelized without limitation. Yes, it is intended to be integrated into complex workflows and used alongside other models. One of the use cases could be its integration into a more complex service or product that necessitates a PVsyst simulation. Please contact our support if you have more questions about a specific use case.
How do I define projects and variants files to be run with PVsyst CLI?
For now, the projects and variants have to be defined via the PVsyst software. However, in future updates, we plan to allow for modifications by integrating the batch mode. This batch mode will be directly integrated into PVsyst CLI.
What parameters can be changed in the PVsyst CLI run?
Currently, you can specify the met files as a parameter when invoking the run simulation command. In the future, we will release additional features, such as the batch mode, which can help changing many other parameters.
What is the price of PVsyst CLI, and how does licensing work?
PVsyst CLI runs on a different license than PVsyst. The pricing is 3,000 Swiss francs per year for unlimited use.
Is it possible to simulate floating systems with PVsyst?
Yes, this was already possible in PVsyst 7. In terms of simulation, aside from the impact of wave motion in deep waters, which remains to be studied, a floating system is very similar to ground-mounted systems. Only a few parameters may change.
When importing 3D drawings, how does PVsyst differentiate between orientations? Where is the orientation tolerance button present in version 7?
When importing a 3D drawing, PVsyst will discriminate between orientations according to a setting present in the project settings in the Other Limitations tab. By default, this setting is a small angle. If you customarily import scenes in which tables have a wide range of orientations that have to be grouped together, it can be useful to increase the default discrimination threshold. This can be done in the advanced parameters. The parameter that needs to be adjusted is discriminating angle for differentiating fields orientations. The orientation tolerance tool present in version 7 is now obsolete because it could lead to electrically inconsistent groupings of tables. It is now recommended to use the orientation management tool or the list and management of objects tool to assign orientations. The orientation groupings should be consistent with spatial proximity and stringing. See also the question on the error messages relating to the orientation spread.
How does the mixing of orientation on given MPPT work in PVsyst 8?
The modeling of the mixed orientation in an MPPT has not changed fundamentally between version 7 and version 8 of PVsyst. However, in PVsyst, it is now possible to mix any two orientations. This pair of orientations can be different subarray by subarray.
Are dome PV objects and fixed tilt objects compatible?
Currently, an east-west dome 3D object can only have a dome-type orientation. This means that it cannot be in the same orientation as a simple fixed tilt table. If you plan on stringing together PV modules belonging to domes and single tables, you should only work with single tables or arrays of tables. Domes can also always be defined as two back-to-back fixed tilt tables.
An error message tells me that one table orientation differs too much from the average orientation definition. What does it mean and what can I do about it?
A threshold angle, found in the project settings in the Other Limitations tab, will cause the apparition of an error message if any one table's orientation is very different from the assigned average orientation. The default threshold is quite small, which may or may not correspond to the type of systems you are working with. To increase the default threshold value, you can change the advanced parameter max spread of orientations between planes. This new default will then apply to any new project you create. See also the question on the orientation tolerance when importing a 3D drawing.
Do you have any advice on the compatibility of PVsyst files between version 7 and version 8?
PVsyst always ensures backwards compatibility, i.e. it should always be possible to import older projects in new PVsyst versions. However, in some cases you may need to adjust some parameters to simulate with the newer version of PVsyst. In most cases it is not possible to use version 8 files in PVsyst 7. PVsyst has separate workspaces between version 7 and version 8, which means that if you want to work with both versions, the workflow is to first work in version 7, export the components and projects, and then import them in PVsyst 8.
Why are there large differences in shading losses between version 7 and version 8?
We have identified a problem with average orientations that will be corrected in patch 8.0.5 or 8.0.6. This bug tends to artificially increase the shadings at low sun angles. Another bug will be corrected in the next patch. It sometimes causes erratic ISO shading diagrams and shading factor tables when using the multi-thread functionality. If you experience this bug while waiting for the update, you can try turning off the multi-thread functionality in the Settings Preferences Running tab.
How to obtain sub-hourly output time series with PVsyst?
Currently, sub-hourly time series can only be generated with the pseudo-sub-hourly simulation procedure. The procedure is found as a PDF tutorial, either in PVsyst via the menu Help PDF Tutorials. It is also a good use case for PVsyst CLI because the procedure involves steps that can be automated. One of the PVsyst CLI script examples included with the PVsyst installation covers this procedure.
Can you offer some guidance about sub-hourly clipping correction?
If you have sub-hourly data, using this feature is quite easy. You need to import the weather data with the custom file functionality and simply check the box Apply in the clipping correction frame when defining the conversion format. You will find more information on the help page link below.
Does PVsyst generate synthetic sub-hourly data?
No, at the moment PVsyst cannot generate sub-hourly data from a time series with longer time steps. You should look at other tools or weather data providers that can help you to do that.
What is the shortest time steps that can be handled by PVsyst weather conversion functionality and the pseudo sub-hourly simulation procedure?
The shortest time step that PVsyst and the presented procedures currently handle is 1 minute.
Some projects now require changing the diffuse definitions for the trackers. What were the changes in version 8, and what should I do exactly?
In version 8, we want to make the modeling of shadings, in particular diffuse shadings for trackers, more transparent. PVsyst 7 had an automatic option which could do different things based on an advanced parameter. This could cause opaque changes to the simulation results. In version 8, this option does not exist anymore. The error message is meant to encourage you to always enter the diffuse shading definition window for tracker objects, which is found in the 3D Scene menu, Tools, Trackers Diffuse Shadings Definition. This functionality will be made more accessible in future updates.
How do I use the zone tool to generate an array of trackers?
A bug currently prevents using the zone definition to directly define trackers that have an axis azimuth different from 0. This will be fixed in one of the next patches. In the meantime, you can define equivalent fixed tilt tables with the zone tool and then use the 3D Scene menu Transform, convert fixed tables to trackers. The fixed tilt tables azimuth should be at 90 degrees compared to the desired tracker axis azimuth. These steps will help you generate trackers at any azimuth in your 3D Scene using the zone tools while waiting for a correction.